you guys the other day, your CBA is tomorrow. That means that Friday you get a free day, unless you're absent tomorrow, and then you have to take the CBA on Friday. So let's take a look at the first one. This does count as a quiz grade, but hopefully we'll just do it all together, and then it'll be done. Okay? So what is an equilateral triangle? Okay, all sides are the same, so draw it. Okay, it doesn't have to look perfect, okay, but you want all of the sides to be the same. Then how long does it say that the sides are? Okay, 12. So every single side on this triangle is 12, okay? These guys match, that guy matches, they're all 12. Okay, what do you know about the angles in an equilateral triangle? All three angles have to be the same or 60. Very good. Now, if you didn't remember that they were 60, here's how you would figure it out. What do they have to add up to? 180. Divide that into 3 equal angles. Each one has to be 60, right? So that means this one is 60. Okay, this one is 60, this one is 60. Now, the next question that I have for you is, how do I find the area of a triangle? Okay, very good. I need 1/2 base times height, which means I have my base, it's 12, but what I don't have is my height. Okay, so what we're going to do is, we're going to take our perfect 12, 12, 12 equilateral triangle, and we're going to divide out only half of it. So, question, if the top angle was 60, but I cut it in half, now it's 30. Oh, that's actually a good idea. Okay, I was going to do it by special right triangles, but I guess Pythagorean theorem will work. Do you like that better?
No.
You can do it either way. It doesn't matter. Okay, so if this is 12 and I cut it in half, how long is the bottom? 6. Okay, let's do Pythagorean theorem. I like that. Most of y'all don't remember the little specials anywhere. Even if you remember them, you don't like them. Okay, so let's do Pythagorean theorem. So I'm going to do 6 squared plus h squared equals 12 squared. Yep. Because remember, we're hiding this side of the triangle. We're just looking at half of it. 6 squared is 36. What's 12 squared? Okay, 144. Then I need to minus my 36 across. You said it's what, 188? Oh, I was like, what? Okay, 108. Now, 108 will divide by a perfect square. I think it divides by 36. So, see if 108 will divide by 36. 36 times what? And if this is really 36 times 3, how can I reduce that? 6 or 3. Yeah, what's the square root of 36? And then remember, you just leave the 3 alone. So what that means is that the height of this triangle from here to here is 6 root 3. And then from there, I would do my area, 1/2 base times height. How long is the base from here to here of the whole triangle, not the little halvesy? 12. And then how tall is the triangle? 6 root 3. Then what's 6 times 12? You have a calculator, right? Yeah. 72. And then cut it in half. So it'd be 36 root 3. Now, quick question. Why can I not combine the 3 with the 36? Because it's inside a what? Square root. And if it's inside a square root, okay, then I can't do anything with it. I have to leave it separate. Does that make sense? Now, if you did your special rights, okay, which I think is easier, but I know some of y'all don't. Okay, if this is 6, what's double 6? 12. And then what's the other side? 6 root 3. So if you do it via special rights, it actually is faster, but you just may not remember it as quickly. Okay. Then it also asks for perimeter. How do you find perimeter? Add up all the sides. So if it's 12 and 12 and 12, what does that add up to? 36. 12 plus 12 plus 12 is 36. Easy? Okay, next one. The question like this on the CBA has a little graph done for you. But you have a ship traveling north. Ooh, hopefully it's not a cruise ship. Okay, coronavirus. Everyone's quarantined. Okay, it's traveling north. After 4 miles, the ship turns 30 degrees east of north and travels 7 more miles. So we'll say that here's 4 miles and then he turns. Okay, if you do never eat soggy waffles, this is east. Okay, and it says that it goes 30 degrees east of north. So that's 30, right? So he's traveling north, and then he turns 30 degrees east and goes 7 more miles. So that means that this side here is 4. This side here is 7. Okay? Then it says, at this point, how far is the port from the ship? Let me make this a little bit longer here. Okay, so let's see. We want to know how far away is he from the port. Okay, which law should I do? Law of sines, law of cosines, or Pythagorean theorem? Which one is immediately out? Oh, you don't see the triangle? It's right here. That's the triangle. Which one's automatically out that you can only use on right triangles? Pythagorean theorem. Pythagorean theorem, out of there. Not a right triangle, bam, gone, not an option. My other 2 choices are law of sines and law of cosines. Okay, but to do law of sines, I have to know an angle and a side that are opposite each other. The only angle I know is here. Now I want you to think about it. If I know that this is 30, do I also know this guy? If they have to add up to 180, and this side is 30, how big does that side have to be? 150. Yeah? Okay, so think about it. If this is a straight line, okay, then all of this has to add up to 180 because it's a straight line. So if I minus the 30 off, that means this side is 150. Okay? And then I want to know this side over here. We'll just call it C. Okay, for fun. So, do I know the angle and the side as partners for sine, law of sines? Should I redraw the picture? Okay, let's redraw it. So here. Does that help? So it's not as picture-y. Okay? Can I do law of sines on this guy? The answer is no. The only angle I have, I don't know the side that goes with it. You can only use law of sines if you have an angle and a side that match. So what I'm going to do instead is law of cosines, which is what we learned yesterday. Now, before you do that, okay, I would make sure that you go through and label all your corners. So let's do A, B, C. Now let's label our sides with letters. If this is A, this is little a. If this is C, this is little c. And if this is B, this is little b. Okay? Then from there, I'm going to look back at my notes. Okay, or I'll just tell you what it is. Okay, your formula is a squared equals b squared plus c squared minus 2bc cosine a. Okay, and it's okay if you don't remember that. You're going to have the formula chart. Okay, this is law of cosines. So then all I would do is I would say, okay, well then a squared equals, what's b? 4 squared plus c is 7, so that's a 7 squared, minus 2bc times the cosine of a. How big is a? 150. And then from there, what am I going to do with this whole side? Type it in. And then that's going to be a squared. Then I'll take the square root. Okay, so 4 squared plus 7 squared. Oops. 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 150. Now, before I push enter, I'm going to check my mode. Okay, I'm in degree mode, which is good. If you're not, fix it before you push enter. So I got that a squared is 113. What's my last step we said? Square root both sides. So square root, square root. Okay, so that side A has to be 10.653. Good? All right, let's do another one. Okay, triangle ABC. Okay, sketch it. It doesn't tell you it's a right triangle, so try to make your picture not look like a right triangle. Okay, then A, B, C. Doesn't matter where you label your letters. Label them the same as mine so that you can do the example with me. But if you put them on different ends, it wouldn't matter. Here's big A, here's little a. Here's big B, here's little b. Here's big C, here's little c. And now I'm ready to label the information they gave me. They tell me that AB is 8. That's here. BC is 11. BC is 11. And then the measure of angle B is 60. Is that law of sines or law of cosines? Cosines. Here's why it can't be sines. Angle and side. Do I have them both? Can't do it. Exactly. So if I want to find AC, that's this side, then I'm going to use my B squared formula off the notes from yesterday. So it says B squared equals A squared plus C squared minus 2AC times the cosine of B. Okay, but remember, you have all three of those listed out on your formula, yeah? Yeah, and they're all on there. The only thing that changes is what goes here. So you're always going to have an A, B, and a C. So if it's B here, those are AC, those are AC, that's B. Okay? So from there, let's set it up. B squared equals, what is A squared? 11 squared plus what, C squared? Minus 2 times A times C. A is 11, C is 8. And then times the cosine of B, which is 60. Then you'll type this entire side in, then take the square root of both sides. Oops. Okay, I got 97. And then if that's what B squared is, what's my last step? Square root of 97 equals 9.849. Okay, that's how long the missing side is. Okay. Okay, sketch 2 cycles of each of the 6 parent graphs. We're just going to sketch sine and cosine. Okay, those are the only 2 that we really covered. Where does sine start? Middle. Now, let's say you forget. What do you have for your test? A graphing calculator. Okay, so if you forget, just graph it in the calculator. Okay? So, sine starts at 0, up, down, forever, never, never. How high does it go? 1. How low does it go? -1. Now, what if I stretch it or something? Then it'll change that. But your regular parent graph is going to go up to 1, down to -1, up to 1, down to -1. Okay, for cosine, what do I change in my graph? It doesn't start middle. Where does it start? Top. So it'll start here, and then it'll go down, up, forever, never, never. Okay, but how high does it still go? 1. How low does it still go? -1. Okay, the only difference is that cosine starts middle. Or oops, top, and sine starts middle. Okay? There is one other graph on your test that it asks you about, and it's tan x. When you get there, just graph it. Okay, look and see what it looks like. Ready to turn the page? Okay. Next one, look at your graph. 2 cosine x plus 2. Okay, first let's sketch a graph. Cosine x plus 2. Which way are we going to shift that? Now, if the x is in parentheses like this, which way would I shift it? To the left. But what if it's like this? That's going to shift it up too. Okay, so remember the difference? If it's inside parentheses, you're going to go sideways on it. But if it's at the back and it's not in parentheses, that's an up 2. So here's 2. This is my new middle. Okay? Then the next thing I notice is I have a 2 here in the front. That's a stretch. Instead of going up 1 and down 1 from 2, how far is it going to go? Up 2, and then down 2. And then where does cosine start? High or middle? High. So it'll be here, and it'll go whoop, 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 forever and ever. Okay? So let's think about the first one. The domain is negative infinity to infinity. Is that true? Okay, yeah, it's going to go both directions for forever. What about the range being 0 to 4? My middle's 2. I went down 2. Where am I at? 0. I go up 2. Where am I at? 4. So is that the correct range? Yes. What if they change the 0 and the 4 to have parentheses? Would that still be right? No. Okay. Next one, it has a reflectional symmetry over the x-axis. Okay, which axis is the x-axis? This one. Is it reflected? No. Now, does it have a reflectional axis across the y-axis? Yeah, look at your 2 pieces. They match each other. So if that had said it has reflectional symmetry over the y-axis, that would have been true. Okay, but x-axis, there's not even any graph on the other side for them to match each other. Okay, so I'm going to put here, it has reflectional symmetry across the y-axis, but not the x-axis. Okay. And then your last one says it has zeros at k pi, where k is an odd integer. What I would just think about there is, so an odd integer just means an odd whole number. So what's an example of an odd integer? 1. Now you could do -1, you could do 3, 5, 7, whatever you want. But think about it. If I look at my unit circle, which you get to use, okay, if I plug in a 1 on that, okay, this one's kind of weird, but you know, y'all take the same test as pre-AP. Okay, so let's say I plugged in pi to cosine. Cosine is x or y? Cosine is the x. At pi, what's the x? -1. Okay, let's look back at our graph. If I put a -1 here and I times it by 2, what do I get? And what's -2 plus 2? 0. So would I be on the x-axis? Would I have a 0 if I plugged in pi? Yes. Okay. The other option that you would have, if you like this better, I don't know if you do or not, is you could do your period and your steps and figure out every time it touches, it's at 1 pi, 3 pi, 5 pi. You could do that as well. Okay? All right, take a look at the next one. Which way are we going to shift this guy? Okay, my phase shift is side to side. Okay, you can put that here. Okay, it's shifted to the right pi thirds. My vertical shift is up and down. Which way is it going, up or down? Okay, down 4. And then my amplitude is how far it's stretched. Okay, 5 doubled is 10. Okay, I think on your test it might use the word vertical distance. That's the same. Okay, so if you see vertical distance, that's just from the top to the bottom. Okay, last thing is the period. Look in the middle. Do I have a number here that's going to change my period? Then it stays the same. What's the regular period for sine and for cosine? 2 pi. Okay, remember 1 is the regular, like, vertical stretch and shrink number. Okay, but for a period, for sine or cosine, it's 2 pi, or 360 degrees. What is it for every other function? Do you remember? 1 pi. So I'm going to put here the regular period for sine and cosine is 2 pi or 360 degrees. Okay, that's in radians. That's in degrees. Okay, remember that for everybody else, it's either 180 or regular pi. Okay, turn the page when you're ready. Good. Okay. All right. Next one, what is the period of the function? Okay, this one is written a little weird, but we can still do it. First question. So I have y equals 1.3 sine 120 t minus 0. Okay, I want you to think about if these are the same. Okay, yes or no? Say that again? That's like an x minus 0, but it's just a t instead. Okay, are these the same? Yes. Think about, what's t minus 0 the same as? T. So they're not putting these parentheses because t is not moved. The only number on the inside is the 120. So what do I do with this number to find the period? Do you remember? Yep. So to find your new period, remember that you're going to take 2 pi and you're going to divide by 120. Now, what if this was already a fraction? What would I do? Flip it and multiply. Okay? So if I do 2 pi divide by 120, what is that going to reduce to? What can 2 and 120 both divide by? 2. So on top, 2 pi divided by 2 is pi. 120 divided by pi is 60. You would look at the answer choices on the CBA. It's in radians on the CBA. Okay, but let's do it in degrees just to practice. Instead of 2 pi, what would I put? 360 divided by 120. What's 360 divided by 120? 3. So that would be in degrees. That one would be in radians. Okay, and like I said, your answer choices on the CBA, they're labeled which one you need. All right, take a look at number 8. Okay, almost done. Okay, number 8, first question. It says, write 2 equations that could represent the function, one in terms of sine, one in terms of cosine. Let's just pick one or the other. Do you want to do sine or cosine? We don't have to do both. Pick one. Actually, never mind. Let's do both. I forgot that the question, you need to know both. Okay, so let's say first that we want a sine graph. Where does a sine graph always start? In the middle. Now, that means I need to find the middle. So, what's the highest point on this graph? What's the lowest point? Okay, so remember, if you need to find the middle, you add them up, divide by 2. So in the calculator, I'm going to do negative 3 plus 1. Then I'm going to divide that by 2. What's the middle? Negative 1. Okay, so if you want to write that down over here, to find the middle, you're going to add the top and bottom, and then divide by 2. So I got that my middle number here is negative 1. That's the middle. Now, where does a sine graph always start? We said middle. So put your little dot right here. That's my middle point. how far to the left did they shift the graph? 2 pi. So I'm going to say x plus 2 pi in the middle. Yeah? Okay, then next question. Normally my graph only goes up 1 and down 1. Okay, but if I went from -1 to 1, how far did they stretch the graph? Okay, I have a stretch there of 2. Okay, then where did they move my middle line, we said? Down 1, right? Instead of keeping the middle at 0, they moved it down 1. And then from there, you can look at the graph and see that would have to be the match. Okay, now let's change it to cosine. Where does cosine start? Okay, so I have to move my little dot that I placed here in the middle. Okay, cosine doesn't start in the middle. Cosine's going to start at the top. So if I put my dot somewhere at the top, I could put it right here. Okay, if this is -1 pi and this is -2 pi, what's in the middle of that? -pi½ or -3/2. Okay, so think about it. If I go from 1 to 2, that'd be 1½ which is 3/2. Okay? So what would I put in parentheses with x for cosine if I only want to move it back 3 pi/2? I would do x plus 3 pi/2. Put your little cosine. Okay, but then do either of the other numbers change? No. How far is it still stretched? 2. And where did I still move the middle? -1. So neither of those should be changing. Okay? Then the next thing that you would want to do is to see if a number goes here. Let's just count the period. Okay, if I go from 2 pi to 0, and then from 0 to 2 pi, did they change the period? Yes or no? Or not sure is fine. Not sure? Okay, how long did it take me to do one full squiggle? How long on the x-axis? 2 pi. What's the regular period? 2 pi. They didn't change this then. That's why I didn't put anything there. So I'm going to put right here, no number because the period is still 2 pi. Okay, remember the period tells you how long it takes your little sign squiggle to go all the way back to where it started. So if from 0 to 2 pi, that's how long it takes me to go up, then down, then middle. Okay, then that's how long my period is. It starts off as a 2 pi, so that means that they didn't change it. Well, then I'm not going to put a number in that spot. Make sense? All right, last two. Turn the page. Yeah. Yeah, but if I want to go backwards, then I have to put a plus. Do you see what I'm saying? Now, you're talking about like if I started here. So if I was going to start here, I would have to put a minus. But since I put my dot here, that's why I put a plus, was to shift it backwards. Okay? Okay, next one. Okay, it says, name angle rotations that could be represented by the terminal side in the diagram. Use positive and negative angles in radians and degrees and angles greater than or less than 2 pi. Okay, so first thing I want you to do is look at your circle for this point. Okay, ready? I'm going to put my circle up here. Where is the x root 2 over 2 and the y negative root 2 over 2? Here comes a circle. Okay? 7 pi fourths, or how many degrees? Okay, write that down. 7 pi fourths and 3/15. Okay, now, the question on your AP, or on your CBA, sorry, is which one is not the same? How do I get to the next coterminal angle for 3/15? Do you remember? What do I add